Yeah, it's not
Can you
because
flash the pipe between the house and the
page, share to your page. That's my page.
put it right.
There you go.
Put it in yesterday.
I think it's my page. This is my personal account.
Great. I was fine until they posted it on
Give
Facebook.
us like 1 second once we go live on.
What they were thinking, but back to beer. We're live on Facebook now.
Just waiting for.
I gotta make a comment. Correct? Good afternoon, everybody. Welcome to Planning Advisory Committee for Monday, October 25th, 2021. Just before we get started off, I'd like to ask everybody to put their phones to mute to help during the meeting. And I'd like to call the meeting to order. So I'd like to open by thanking the members of the Planning Advisory Committee, council staff, the various presenters in our community for their active participation around this learning journey as we seek to understand more about land-based agriculture. I have a few housekeeping items to review prior to calling the meeting to order. So due to the pandemic, the meeting is available to the public to live stream to Facebook, and minutes will also, once approved, be posted for public viewing. The presenter slides will be issued along with the approved minutes. There's a significant amount of information to work through. Therefore, we want to be respectful of the time allotments made for each presentation. During the question and answer portion of each presentation, I will give the floor to members of the PAC in the order requested. Each member may pose one question and one follow-up question, then the floor will be ceded. Once each member who has a question has posed their question, then if time allows, additional questions may be posed by members in the same sequential manner. 15-minute break is provided between each presentation to allow for technology changes or cleaning between presenters. And so really that amounts to a 30 to 40-minute presentation and then a 5 to 15-minute Q&A, depending on the length of the presentation and so forth. And we'll try to stick to the timelines as close as possible. On your agenda, you'll see a call for motion to recess at the end of night's sessions, and again at the end of the sessions tomorrow. All the learning plan material will be delivered inside one meeting package, and we'll have one set of minutes for all the presentations. So what's going to happen is we're going to have today's sessions, and then we'll adjourn after them and reconvene at 9 tomorrow and so on. So it's just all one meeting package. So that's how it's going to play out. So already called the meeting to order, and certainly we've taken attendance. We've got a quorum, and I'll look for an approval of the agenda. Counselor Cushing,
Seconded by.
we have a seconder, yeah. All those in favor?
Aye.
All those opposed? Motion carried. Thank you, Councilor. We've got quite a slate of presenters today. We have Inka Mileski at 3:30. At 4:45, we have Jim Dustin. At 6, we have a private citizen from Chile. And again, maybe I can go through tomorrow's as well. Tomorrow we have Gregor Reed, we have Boreal Salmon, Tom Smith and Stacy McCarthy. And on Thursday, November 25th, we have Nova Scotia Fisheries and Agriculture. And again, those are all outlined in more detail on our Facebook page and on our website under the PAC Planning Advisory Committee agenda. So without further ado, we'll invite Inka Mileski, Research Associate, Dalhousie University, to present to the Planning Advisory Committee.
I'm just waiting for her to reconnect.
Yeah, and she's just reconnecting for everybody out there. Bear with us. Good afternoon, Ms. Mileski, and are you able to hear us, and can we hear you?
Your audio is still connected.
Oh, still. Good afternoon, Ms. Mileski. Thank you for joining us. I'm not certain we can hear you. We can't hear you.
Hello?
Hello, there we
Hey.
go. Great. Welcome to the PHC, and thank you very much for sharing your thoughts that you are going to have on agriculture today. Very much appreciated. We are a bit.
Great.
We are time limited. We have about 40-45 minutes for you to present, and then 5-10 minutes of Q&A. So if you don't mind, we'll start.
Launch right into it. Yes. We all have screen share, do we? So I can just throw up these slides. Yeah.
Absolutely.
Do you see the slides or?
Not yet.
They're here.
Check her.
There we go.
How about that?
We do have them. Yes, thanks.
Perfect. Okay, well, I have to say thankfully I don't do a lot of this. There we go. So for those who perhaps don't know me, my name is Inka Mileski, and I'm a research associate in the biology department at Dalhousie University. I've been a marine biologist for the last, well, almost 40 years. So I've spent the last 20 looking at impacts associated with farming salmon or aquaculture in general. What I'd like to do today is to just give you a bit of an overview of intensive flow-through land-based fish farms. It's not an exhaustive review. I don't think we've got time for that, but I hope that I'll be able to give you some information to work from that may help some of your deliberations and as part of this learning workshop. So the outline of my presentation is to look at what's involved in raising fish and flow-through systems. I want to look at specifically the waste characteristics and the treatment options. I want to briefly touch on what are called impingement and entrainment issues, meaning water that's taken into the intake and what are the potential issues associated with that. And just briefly a little bit on the regulations that are associated with intakes and effluent from flow-through land-based fish farms. These examples I have here on the screen are just some land-based fish farms are completely contained, meaning they have a roof over them. Some of them are open, as you see in the middle photograph. They vary in scale and what is being farmed. Mostly in the world, these land-based intensive land-based flow-through fish farms are primarily raising freshwater rainbow trout. A lot of that is being done in Europe. There's, of course, it's been done in Canada, the United States, and Chile. These are some of the countries that, apart from those in Europe, that are doing land-based intensive freshwater fish farming. And usually the discharge are to streams and rivers. And that's where most of the research has been done, is on these freshwater systems. So there isn't a lot to go on in terms of looking at the scientific research to see what impact or potential impact land-based systems that are discharging into marine environments. And the issues are slightly different. The major concern, the concern for freshwater systems is the amount of dissolved phosphorus. Because phosphorus in freshwater systems is what is called a rate limiting nutrient, meaning it is that nutrient, that element, phosphorus, that will determine uptake by plants and drive what is called the eutrophication process. And I'll go into a little more detail on that. But in marine systems, what we need to be concerned about is the nitrogen. And nitrogen in marine systems is the rate limiting nutrient. So freshwater and marine systems have different rate limiting nutrients. Phosphorus in freshwater systems, nitrogen in marine systems. So raising fish. Well, it's not difficult. You have some inputs, feed plus some disinfectants, antibiotics and pesticides if they're necessary. And the outputs are a range of outputs, both dissolved and solid. So you have feces, you have respiration, which is CO2, but also through the gills, a lot is where a lot of the nitrogen is excreted as well. Urine, feed losses in the form of dissolved and particulate carbon, nitrogen, phosphorus, plus you have whatever chemicals are being used, whether they're disinfectants or pesticides. Then you have viruses and bacteria if they're present. So you've got particles of bacteria and viruses that may be shed through the grow-up process. Now, estimating how much waste per ton of fish production really varies on several factors, including the species that's being raised, the type of feed, feeding efficiency, even the type of the feed will influence the type of feces, whether it's a more solid feces or a loose feces. And if that feces is a little bit looser, then the turbulence will break it up into much smaller particles, which has an impact on whether they're captured on any kind of screens or drum filters. So those are all things that are discussed quite extensively in the literature. So for example, dissolved nitrogen from salmon is estimated to be about 32 to 36 kilograms per metric ton, whereas sea trout, it's 40 to 48. So there is this, you know, a fairly significant difference between species in terms of the nitrogen release. Now, the amount of suspended solids, which are largely the feces in uneaten feed, well, they can vary from between 15 to 19% of total feed, or, you know, 147 to 318 kilograms per metric ton of production. Again, it really depends on the species. So calculating the amount of waste that's discharged is really going to be, you know, a plus or minus calculation. It's an estimate. It's an imperfect calculation. But generally this will give you a ballpark of what can be produced. So the treatment options for this waste that's produced, there are three categories of pollutants: the solids and the nutrients, and the chemicals, which are the trace metals in the feed, the antibiotics, the vaccines, hormones, pesticides, and disinfectant. Now we can go to, let me see if this will click, but there we go. Hopefully this will load for me. But what I wanted to send you to or show you is the federal government operates a national pollutant, national, I guess they call it public open information data. And if we scroll down here, we get to land-based and freshwater data. And the most recent data for land-based and freshwater systems. So this is where they're reporting all the antibiotics, pesticides, disinfectants that are used on all the reporting land-based and freshwater fish farms across Canada. So this is a database. The latest data is only, as you can see, is 2018. And it doesn't seem to have any data for 2019 or 2020. So that's, you know, you can look at that at your own kind of leisure. So let me just go back to, now I probably am going to, I shouldn't have left, but now I'm going to get myself in trouble here. There we go. There we go. Can you hear me?
Yes. Yes.
Yes, okay. And I'm going to share screen right there. There we go. So I won't do that again. I thought it would be a little easier to do that. But anyway, you know what it is and it's in the presentation. So there's a wide range of waste treatment options. So there's a wide range of waste treatment options, settling ponds, mechanical screening, rotary drums, sludge cones, thickening agents, and they deal with some or all aspects of the waste. What's very, I won't say popular, but it's frequently used in Europe are these constructed wetlands. Some of them are natural wetlands where they simply, the effluent is piped through a wetland, either artificially or real, that's constructed, and the plants are there to take up some of the nutrients. The type of gravel bed that's under them is supposed to collect the solids, and then as it passes through this system, then there's an outflow and the waste is somehow treated. The effectiveness it really depends on many factors, but it is primarily done on freshwater systems. This is what will be done on freshwater systems where you can create sort of artificial marshes or ponds. What is a second method that's popular, and that is these drum filters and screens. And as you can see the photo there, the treatment efficiency of these rotary drum filters depends on many factors. Because it is a mechanical system, it's also subject to sort of higher maintenance requirements so that the screens are kept fairly clean and not clogged so that they become efficient. The mesh size matters, the characteristics of the feed. It depends on how fine the feed is, and the particle distribution in the water. There's a system that backwashes those drums that keeps the mesh open. And if that's not working properly, then you're not getting as efficient a treatment of the waste. And you can also, as this particular study did an evaluation of the drum filters, they found that the efficiency is not 100%. It's not even 80%. It's probably in the range of 40 to 60%. 40 to 70 is probably the peak efficiency for collecting the waste. And again, it's primarily solid waste, the feces, the uneaten feed, but the dissolved nutrients like nitrogen and phosphorus, and antibiotics and pesticides or whatever, they pass through these drum filters. So just as an exercise to get a sense of what a proposed system, the efficiency of a proposed system and the amount of waste that could be produced and discharged. So I took the numbers in the project proposal and I ran them through some calculations. And if we start here at the top, the estimated fish production in the first stage is 2,000 metric tons. It's suggested that the feed requirement would be 2,500 metric tons. So the feces produced, the literature says anywhere between 15 and 19%, really depends on, on practices. I've used to calculate the lower sort of conservative 15% that feces to come up with a number of 375 metric tons. So, a farm producing 2,000 metric tons of fish, a land-based fish farm, 375 metric tons of solid sort of just waste would be produced. Now, the dissolved nitrogen is anywhere between 32 and 44 kilograms per metric ton. And I've used this conservative 32 44 would be if it was growing, say, trout. 32 would be if it was salmon. This is the value that's given most frequently for salmon, 32 kilograms. And so I've estimated that at 64 metric tons. And then the amount of uneaten feed would be 3% of the total feed requirement. And that's generally the literature uses that value of 3%. And so we're looking at about 75 metric tons. So for a total waste production over the 18 to 24 months would be 514 metric tons of waste from this amount of production. Now, if you're going to treat this waste and you're going to capture, say, 85% is what the screen efficiency is, then what's not going to be captured by producing the feces and the solids, the uneaten feed, is about 67 metric tons. And none of the dissolved nitrogen would be captured by the screens because it's just going to go pass through. So we're looking at about 131, metric tons over an 18 to 24 month period. So we're looking at discharges from a farm like this of 5 to 7 metric tons per month of waste being discharged. And as you increase the production of fish, you're going to increase the production of waste. So we're looking at 550 metric tons, 5,500, and you go through the calculation, you come out to about 14 to 19 metric tons of waste per month. So, so you've got this waste. What's the consequence of discharging this amount of waste or any amount of waste from any system, whether it's a sewage plant or a fish plant or a septic systems or runoff? These wastes that are discharged have consequences. And of course, it depends on what are the characteristics of a particular bay. What is the size of the bay, the amount of time that the water is resident in the bay, meaning its turnover, the currents and the tides. It'll depend on whether the discharge from a fish farm is added to, say, sewage discharge, that is the discharge from a sewage plant or a fish plant, land runoff, and septic systems. And of course, the amount, the volume, the characteristics, and how frequently or what's the duration of the waste that's being discharged. As I said, the nutrient loading to marine systems leads to a process or sets in motion a process. It's referred to as eutrophication. Where there are these biological and ecological changes that take place in the ecosystem. And the beginning of that eutrophication is often characterized by the appearance of what are called nuisance algae. These are annual algae, like this bright green algae that you see here on the rocks, or here on the rockweed, you get this sort of filamentous brown algae that's very slimy, epiphytic, it's growing on the rockweed, or you get these mats of filamentous algae. And you can, fish farmers, lobster fishermen have pulled up traps that are covered in this slimy annual brown algae that signifies there's some available, a high nutrient load in the area. And the first species that take up those nutrients are what are called these nuisance algae. They're very efficient, very effective at taking up these excess nutrients and turning it into production. And when they do that, they can, and if that nutrient loading is continuous in a certain area, then these mats can smother clam flats, they can smother and basically kill rockweed beds. They can lead to harmful algal blooms, they can smother seagrass beds because of this. As I said, they're very efficient. They're the first species that take up these nutrients. When these annual algae die, they decompose and create low oxygen conditions. And this changes the environment. It changes the kind of invertebrates that can live in a low oxygen environment. Potentially fish will avoid those areas. And as these things continue, you get what are called dead zones. And nutrient loading to coastal ecosystem combined with climate change contribute to the creation of marine coastal dead zones. This is a growing problem worldwide. And there have been incidents where there have been low oxygen conditions, particularly around open net pen salmon farms, that have caused death of the salmon in the net pens, but have also created these annual algae and areas of reduced biodiversity around these net pens. So it's a very serious problem, and one that is, there are no restrictions on nitrogen releases from these types of operations. So, that's, on the waste side, but on the intake side, usually there are screens like shown here below. This is a screen that's put on the intake, and it has a mesh size of 1 inch or approximately 25 millimeters. And in the project that's being proposed, there are 7 of these intakes, which will be increased to 14 intakes. And the concern, I think, that is out there, and it certainly is a concern that is addressed in very large operations like power plants, where they do have intake screens for cooling. There are some restrictions on that. And there are even, DFO has a code of practice on freshwater intake systems. So fish farms that are operating, that are drawing water from rivers, have these codes of practice and on how to limit the potential intake of fish, primarily small fish, into their intake waters. So what I think is a potential concern in coastal areas is the intake of marine invertebrate fish, the eggs and larvae of marine invertebrates and fish, particularly during periods when these species are in the area and may be spawning. This type of system would be ineffective. Well, it would be very effective in drawing in the eggs and larvae of invertebrates and fishes, because these eggs and larvae are very small. For example, the clam eggs are 0.07. This is actually a clam egg here, and under a microscope, and it's about 0.07 of a millimeter in diameter. And herring eggs are a little bit bigger, but they're still only 1 to 1.5 millimeters in diameter. The larvae, the larval stages of marine invertebrates, and every species has one, whether it's a clam or a fish or a mussel or lobster, they have a larval stage. And clam larvae are 0.1 of a millimeter, and lobster larvae range from 2 to 14 millimeters. Now, this is a lobster. It's not a larval form, it's a juvenile. So the larval form would be about, half of that in size. And copepods, which are the base of the food chain, which are these species right here, those are only, at most 2 millimeters in length. So these very small eggs and larvae would be drawn through these intake, and we're looking at intakes of about, I think the proposal said 6, let me just look it down here, something like 6 cubic meters per second. Well, that kind of works out to about 500 million liters of water per day would be drawn into the system from the bay. And again, depending on the time of the year, particularly in spawning periods, depending on the species, the chance that these might be entrained into the cooling system, into the intake rather, is quite high, because the mesh size on these filters are actually quite large. And of course, other species might be what are called impinging on these screens. So whether they pass through or not, they might become stuck onto it. So there's some issue with that as well. So that's the entrainment and impingement. And frankly, there's really been no studies have been done. I could not find in the literature anywhere that they have assessed, how many eggs and larvae could be withdrawn into these intake pipes, or adult organisms that could be trapped on the screens on these systems. So I really don't know, and I don't think anybody can say, but it certainly can happen. It's just an obvious thing because of the difference in size of the mesh on the screen and the very small size of these eggs and larvae. So we really don't know that. So the final thing I want to talk about is a little bit about the regulations. And I looked through the literature to see, how these intensive flow-through systems are managed elsewhere. In the European Union has been working on a water framework directive to reduce and treat waste from land-based fish farms. And I tried to get an update, and the most recent update is, while they're still working on it, there is no consensus on how to establish the regulations for these systems. In the meantime, every country in the European Union has different regulations regarding waste control, water quality, and monitoring. What we have in Canada is the National Aquaculture Public Reporting Data, which I sent you to, and that is the only requirement for reporting to the government data on what pesticides or antibiotics, what chemicals are you using on your farm. They clearly have to report escapes. They have to, escapes, and they have to report diseases. Certain diseases, not all diseases. The Nova Scotia is in the process of developing an environmental monitoring program for land-based aquaculture. They currently don't have one, but they do have sort of a plan, a guide. I won't take you to the link because that'll just mess up our system here. but there is an application that has to be done. There's under the Environment Act, there are concerns around water withdrawals. And I'm not sure if that applies to freshwater, to marine systems or just to freshwater systems. I know it applies to freshwater systems. And then, of course, under the Navigation Protection Program of Navigation Canada, Coast Guard, you do have to have, if you're going to put a pipe into a marine system, you have to apply to that department to get permission to do that. So that's kind of the regulations. Well, they're not even regulations. They're really, right now, they're just guidelines. But there is no either federal or provincial regulations that says, you know, the quality of the effluent coming out of your pipe has to meet this kind of standard. There are some places in Europe where there are those standards, particularly in freshwater system, it's for the phosphorus, and in marine system, it's for nitrogen. There are some requirements on total suspended solids, but those are not those are not regulations that we have in place in Canada. And this is just a kind of an overview from DFO on who manages what in terms of fish farming in Canada. And we can see that, as I said, that the drugs and pesticide approvals are shared across jurisdictions. Food safety is a federal jurisdiction. Introductions and transfers of species, that's again shared. But day-to-day operation, land management, and site approval, except for Prince Edward Island, which the federal government seems to have more responsibility for, but for the rest of Canada, for example, Nova Scotia, Newfoundland, and New Brunswick, those are provincial responsibilities. And in British Columbia, because of a court challenge, the federal government has more oversight over the day-to-day operation of these facilities. And that just about that concludes my presentation. So if you have any questions.
I'll open the floor up to questions, and Jenny will keep track of who has the first question. Thank you. Thank you very much, by the way. Fantastic presentation. Very informative.
Right.
Oh, Mr. Hilton, Councilor Hilton, you have a question?
Thank you, Inka, for joining us. So for a community like us looking to adopt or expand on the policies related to on-land aquaculture, and knowing how dependent we are on the fishing industry and the concerns that our residents have, you know, when you look throughout the province and there's a number of closed containment systems, what direction would you recommend, or what are best practices that we should be looking at when we make these policies?
Well, this proposal isn't a closed containment system.
I know.
It's a flow-through system. And right now, these very intensive land-based operations are not well regulated. And as I just pointed out, Nova Scotia is just in the process of developing some of those. And my view is that before we end up licensing these operations, we need to really know much more about what the potential impact of withdrawing water and also discharging water into marine systems. And as I said, there's so little literature has been done on these types of operations that I just myself, I would like to see sort of a suspension of any authorization, not just, you know, really across the maritime regions, whether it's BC or maritime Atlantic Canada, that let's take a look at these systems and make sure that we have all the measures in place, the right regulations to ensure that the marine environment doesn't take another hit. Because as I said also, adding more nutrients into coastal waters on top of climate change and ocean acidification, it's diminishing the capacity of our coastal environments to do what they should be doing, which is producing food for us for free. So I don't know if I'm answering your question, but right now I would advocate for extreme caution in terms of proceeding. And in the absence of knowledge, we need to take a precautionary approach and wait until we do some of the kinds of studies that need to be done to figure out what kind of regulations do we need to protect the coastal environment.
Thank you. Thank you for the presentation. Correct me if I'm wrong, but did you say that most of the studies that have been done has been with freshwater farming and not so
Yes.
much?
Yes,
Okay. But we really don't have a
Yes.
lot of information.
because as I said, this practice of having land-based systems really emerged out of growing trout. And like I said, a bulk of that production is done in Europe, and it's where they've had a 50 or 60-year history of doing this on land-based systems and drawing water from freshwater rivers and streams and effluent into freshwater streams and rivers. So that's where most of that research has been done. Now, there is one researcher who a few years back, probably 5 years, the Environment Canada had a program, and actually it's been since terminated. So Benoit Lalonde was a researcher there and did the only 4 or 5 studies that have been done in Canada on discharges from freshwater land-based systems and their impact on streams and rivers. And he did most of this research in Nova Scotia and found that, antibiotic residues and as I said, phosphorus levels were having effect to total suspended solids were changing the bottom of streams and changing the diversity of the biological community. So, that's where the research is. And there's, as I said, only one researcher that I'm aware of in Spain who has done work on marine systems, intensive flow-through systems impacting marine systems.
Thank you.
Thank you. Inka, I gather that the database maintained by the federal government is a voluntary reporting system from the agriculture to the government. If that's voluntary, is follow up by the regulators, because it goes to federal and it goes provincial? Is there any follow up after reporting of an escape or any nutrients or anything?
Good question. I don't know. It surprises me a little bit. I have to say, if you look at the 2018 database for Nova Scotia, there appear to be only 2 land-based farms that have reported to the registry. And I don't know, but I think there might be more than 2 in Nova Scotia, but I could be wrong. I don't know. I don't know who's checking. I really don't. It is voluntary, and yeah. There's no independent oversight. That I'm aware of.
Our planner has a question.
No, I'm just, and I don't want to, I'm just very curious because when I've spoken with the province on this, a lot of the things that you're saying is contradictory to what the provincial department that regulates aquaculture has said to me. Which, is very upsetting because we're making a decision when it comes to this kind of thing, you expect them to regulate it the way that they're saying. So like part of what you've said is that there's no, what I'm understanding, and I just want to clarify that, is that there's no guidelines or legislative standards when it comes to the affluent percentage that's going out, like what's contained in that affluent and what it's going out. But it is regulated, is my understanding. Like if there isn't legislation, but because they have to have a license process, they are required to, they base it on the system itself and the site itself. So they look at the receiving system and what that system was like prior to it going in, and then they look at the impacts on that system and they regulate it. I understand quarterly they do testing and it is reported back as part of their licensing process.
So what are they regulating? That's, my question is, for example, the only place that well, there's several in Canada that, for example, sewage effluent. When the operator has to take a sample of the effluent, it has to meet certain nutrient, like the nitrogen level has to be at a certain level. The total suspended solids have to be at a certain level. The BOD has to be at a certain level. To my knowledge, that kind of, and that's the kind of reporting that I think is particularly useful as a regulation, that, to my understanding, isn't what is required for fish farm, the discharge from a land-based fish farm. I could be wrong, but I don't see it in the regulations or in the guidelines. I don't see those numbers. So
I didn't either, so that's why I was wondering. That's why I called in those questions, because there doesn't seem to be actual regulations that are written.
yes.
Or guidelines talking about it, but from my understanding with actually speaking to the staff, it has to do with the site itself and the receiving environment, and they
Yes.
base, and then they look at based on that baseline and keeping it at the same similar treatment, and then that they do. I understand that there's the I'm not questioning you either. I just want to make that clear. Like I really am just trying to understand it because
Sure. Well,
system that's where they're
and it is I would say it's a little it is confusing, because if you were to ask those the environment or NSDFA people, what are you monitoring? So they say there's monitoring. So like when I say I'm monitoring my health, I'm taking my temperature. I've got a measurement. My body temperature is 34.9 degrees. So what is it that they are monitoring? There's one thing to say there's a monitoring requirement. I know there's a monitoring requirement for open net pen fish farms. And I know that has to happen once a year. And they have to measure the sulfides, they have to measure the redox, and then they get a number. And that number is reported to the province. But, when I see the province saying that, under the minimum compliance requirements for land-based fish farms, this is directly from this is a link to their website. NSDFA is developing an environmental monitoring program for land-based aquaculture. The goal of this program will be to examine the relationship between aquaculture and the local environment. At this time, containment of fish must be described within the fish management plan. So my understanding, and that's the most recent document, is they don't have an environmental monitoring program. They're developing one, but it's not in place. So we can even, I mean, I don't want to go to this link, but if you go to this link, if you have my presentation, and you'll get this document that will come up, new land-based development plan guide for, you know, Nova Scotia, and you'll come up with, and these are just tells you that, yes, you have, they'll tell you how much water you can discharge at what rate, but it doesn't tell you what's in the water. Or you can withdraw so much water, but you're not, you know, there's a, I don't even know if there's a requirement for a certain screen to be on the end of pipe. This is something that is unclear. And if you could, you know, pin them down to some actual practices like those practices that are available for open net pen farms. Now, those are quite explicit about how to sample, where to sample, what to sample, and the reporting requirements. And if they exceed a certain limit, then you can't farm anymore. It's very explicit, but I think this whole area of land-based flow-through systems is very new, and the kinds, there's just, to my knowledge, the regulations or guides or codes of practice are untested. So I'm with you on this one, Jenny. I find it really, I'm struggling. I read all the documents that are available that the provinces put out, and I'm looking for the kind of meat on the regulations that you would have, say, on open net pen farms.
That's what I was looking for as well. Yeah, because I mean, I'm the planner, so that's what I do. I look for policy and I couldn't find it. So I'm going off of verbal conversation.
Yeah.
Thank you. Councilor Hilton, you have a question?
Is there anyone else first?
I don't think so. Here we go. Okay, we'll go to Councilor Hilton and then Mr. Warner.
So I'm happy that we're talking about water quality. One thing I don't like that you said is that, you know, they possibly could start and then test the water later to see the changes. If there is changes, do you have any examples of where that, you know, in other even open pen farms, where that has changed the quality of the marine life, you know, around there? You know, lobster fishing is one of our biggest industries here. We bring in 50 million pounds of seafood to our town wharf. If that changed in any way, could that affect that in any way? You know, the taste, the quality, whatever.
You know, those are really good questions. And, you know, I just published a paper with my colleagues earlier this year. We looked at, again, because land-based, these intensive flow-through systems are really very new. You know, they're relatively new. I'd say in the last maybe 5 years, that they have really grown in interest, that people are looking to move from open net pens to moving these systems onto land to try to control waste, to try to control disease problems, to try to control the use of you know, antibiotics and the need for antibiotics and pesticides. So that is a movement that is happening, and you know, it's, for me as a coastal ecologist or marine biologist, I welcome it, because right now any open net pen system is just, the waste is being distributed in the environment. And there's lots of research done on ways in which this has altered around the net pens, and what are increasingly people, because these farms at sea are becoming very large, they're growing over you know, 3,000 to 9,000 metric tons on a farm. These wastes are being dispersed by currents and tides over a larger and larger area. So most of the work that I've done is in Port Mattoon, where we've published a series of 6 papers looking at the impacts the fish farm that was there is no longer there, but the fish farm that was there, and again, it all depends on the environment. Port Mattoon Bay, where the fish farm is relatively shallow. It's got a recirculation so that the waste isn't being taken out of the bay. It's actually recirculating within the bay. And because the farm is tucked in behind an island, it's also restricted where the waste is going. And in those studies, we found several things. We found that the eelgrass beds were being affected. We found that the nitrogen load from the farm was the most significant nitrogen load to the bay after atmospheric deposition. So it wasn't the, septic systems, it wasn't land runoff, it wasn't anything else, but the fish farm was the largest point source of nitrogen release to that bay. And finally, we found the way that the lobster fishing has been done in that area, we had an 11-year data set where we looked at catch rates in 5 regions around the fish farm that are traditional areas that fishermen fished for probably almost a century. We could compare or look at catch rates when the farm was in production, dispersing waste, and when the farm was fallow. And when the farm was in production, catch rates for market-sized lobsters dropped 52%. And the buried females that were caught in the traps dropped, I think, 57%. And when the farm wasn't in operation, catch rates went up. When the farm was not in operation, the catch went up. When the farm was in operation, catch went down, up and down over 11-year period. So we could actually document that. So that was, and we proposed that in those studies or in those results, why were the catches changing? And we speculate, because this farm had been there for a very long time, that lobsters are extremely sensitive to odors, and that the quality of the bottom around the lobster, around the fish farm, and the release of nutrients like nitrogen, the nitrogen compounds would be picked up by the lobsters, and they would avoid those areas. They don't like foul areas, particularly that at this time when the lobsters were getting ready to spawn, and the females were even more sensitive to those odors, and also the quality of the water. It was quite turbid. So that's one of, we have to test that hypothesis, but there's another study that was done in New Brunswick that had a different result. Not that they did a catch study, but they looked at distribution of lobsters. The difference was the study in New Brunswick had very deep water, really high flushing rates, and a very small fish production smaller fish production compared to Nova Scotia to Port Mattoon. And it hadn't been there, the farm in New Brunswick hadn't been there. In fact, it was just a brand new farm. So there are lots of factors, but we have seen this, and there are other studies that have looked at how far the impacts from open net pen farms can be measured, and we can see changes in the biological community, in nuisance algae, in loss of eelgrass beds, and things like that. So that's a kind of a long answer to your question, But the bottom line is this stuff for intensive farms on land-based systems has just not been done.
Mr. Camillo.
Actually, I think it's gonna be answered better by someone later on, so I'm gonna pass on.
Okay, any additional questions? We are at 4:30, but there's enough time for another one, certainly, if anybody has one. Ms. Molesky, any additional comments about the presentation or?
Well, it's just, you know, as I said, if you have any questions or, I mean, I've, as I said, I've scoured the literature. It's, you know, this is not where I've done direct research as I have done on open net pens in whether it's Shelburne or Port Mattoon or here in New Brunswick. But I do know the literature, and I'm hopefully somebody, perhaps there's someone else. I know Gregor Reed I know him quite well, and perhaps he has more experience with flow-through systems than I do, but we certainly don't have many in New Brunswick or Nova Scotia or, you know, Atlantic Canada for that matter, or even Canada. So good.
Well, listen, I would like to thank you on behalf of PAC for your time and efforts and your expertise. Very good presentation, and I think it has moved the needle definitely forward in terms of our understanding. So for that, we're very much appreciative. Thank you.
Well, you're welcome. And if any of the counselors have any questions, you can certainly email me, and I will try to, if I don't have it at my fingertips, I can do the research.
Absolutely, very much appreciated. Thank you.
You're welcome.
So Jenny, we're going to take a pause, and we will be reconvening with Jim Dustin. Welcome back, everybody. A wonderful first presentation, and we're going to bring Jim Dustin in, biotechnology. He's a professor of fin fish aquaculture at Dalhousie University. Hi.
Hello.
Hi, Mr. Dustin. You can hear us as well?
Yes, loud and clear.
Okay, very good. Thank you for coming in. The PAC appreciates you taking your time to present to us. We have about an hour, you know, and some time for questions at the latter part of that hour. So
Sure.
if you wanted to start sooner rather than later, we can have a bit more time for the Q&A. So
Yeah. Okay. Yeah. Well, I'm ready. So I'll share my screen.
perfect. Thank you.
Okay.
You can see that. Yeah.
Okay. All right. So, well, thank you very much for inviting me to present. Yeah, my name's Jim Dustin based in Truro. I've been teaching finfish aquaculture since 1995. So I've got I've seen the industry change and grow down the years. So my mandate, or I was invited to provide a sector overview, including vocabulary, innovations over the last 5 years, and a sense of where the industry is growing. So I have 20 slides, and I've attempted to stick to that title. The first graph here is just to emphasize how important aquaculture is globally. So from the FAO, the blue here is aquaculture globally in 2018. dark blue is freshwater and light blue is seawater. So, and the orange here is the capture fishery, which is pretty much flatlined at around 90 million tons a year. And we can see how aquaculture is almost equal now and soon will surpass the capture fishery. So aquaculture, we all know aquaculture is important. There's globally, that's just a bit of evidence there. So moving on, slide 2. So in Canada, Atlantic salmon dominate the industry, and hence they dominate this picture. 75% of Canadian aquaculture is Atlantic salmon. Almost $1 billion 2019, and about 118,000 tons. So it's quite an important industry, particularly for coastal and rural communities, as we know. Next slide. If we just look at top right for starters, it's annual production in tons, and it compares the East Coast with the West Coast of Canada. This is Atlantic salmon production. So the East Coast is the dotted line here, and its production's been pretty flat since around the turn of the year 2000 here. So it's around about 30,000 tons a year from the East Coast. So, New Brunswick, Newfoundland, and Nova Scotia. The West Coast is dominant, as we can see here, and it's approximately 90,000 tons a year. And the last data point there is 2019. So that summarizes production. Just jumping down to the bottom here, this is a measure of the demand of Atlantic salmon in North America, and these are imports into the US. Fillets, Atlantic salmon fillets, and you can see here that the demand is large and it continues to grow even in a pandemic era. There's a tremendous demand for Atlantic salmon. Millions of pounds here. So this hits, so the year to date, 250 million pounds. US have imported, 113,000 tons of fillets, which are, the rack and the heads have gone by this point. So there's a tremendous amount of money to be made selling Atlantic salmon. That's what I was who sells? So Chile export a lot of salmon to the US. The red bar here, and the blue bar is Europe and Canada. I'm not sure how much Canadian production goes into the US, but it's significant. And just at the bottom here, just in perspective, Norway produces about 1.3 million tons a year. So the Norwegian production is about 10 times more than Canada, and so traditionally Norway sold into Europe, but they are increasingly selling fish into North America because there's to satisfy the demand. So this little graphic here just sort of shows 90,000 tons on the West Coast, 30,000 tons on the East Coast. That's whole salmon production. Chile, their transportation costs are, well, it's a long way, but they're a dominant exporter of salmon into the US. So I'd say Chile are outcompeting and have outcompeted Canada for many years, actually. So anyway, that's kind of an overview of production. And The next, so British Columbia has, the recent news is shutting down salmon farms in BC begins in 2022. The federal government confirms plans to end open net fish farms by 2025. So this was just late last year. The beginning of the end of the salmon farming industry in BC as we know it. So production in Canada is destined to decrease. And some of the big companies have, that's why they're looking to the East Coast, I think, for opportunities to expand. Oh, just a bit of the arbitrary and unfair. Maui questions motivation for ejection of, so it's an ongoing battle right now. There's the ex-fisheries minister, Bernadette Jordan. So Maui is the biggest salmon farming company in the world. They used to be called Marine Harvest. And I just put in a couple of papers here, scientific papers. This one seems, aquaculture mediates global transmission of a viral pathogen to wild salmon. This is very prominent, and this virus was, led to the decision, I believe. But there's differing opinions on that. Scientists are not unanimous. There's another group of scientists who say that the virus has been in British Columbian waters since as early as 1977, prior to Atlantic salmon farming. So it's not clear to me where the truth lies, but certainly it seems that net pen farming in coastal British Columbia is going to decrease. I think that's for sure. State of the industry. So potential alternates to coastal open net pens for growing Atlantic salmon. So in Canada and Norway, everywhere where Atlantic salmon are being grown, there are concerns about production in open net pens. And I'm sure you're well aware of that. And so there's these new ideas coming out, big plans for innovative salmon venture proposed for Maine. So this is clearly a net pen in coastal waters, but it's sort of fully enclosed to prevent pathogens getting in, or anyway, that's one idea there. Another idea is moving it offshore, as this picture shows. Who knows where it's going to go. The bottom one is Sustainable Blue, a fish farm near Windsor, Nova Scotia, fully enclosed, closed loop land-based facility. So there's a lot of investment going into these fully closed loop land-based systems. We took our students to Sustainable Blue in September, and there's some big expansion going on there. And they hope their next target is to produce 1,000 tons of salmon a year, which is quite a big number, but it's quite small compared to the 90,000 tons that are of total of Canadian production. Anyway, that's, so, yeah. Now, land-based salmon farming, it seems Canadians are supportive of land-based salmon farming, and the community of Yarmouth seem, that's you've you are supportive of land-based systems. Globally, there is currently massive investment in RAS systems for growing Atlantic salmon. So RAS is just recirculating aquaculture systems, the reusing of water to grow fish in a biosecure, highly controlled environment that looks perhaps, well, something like the previous slide showed sustainable blue. Here's another RAS system that's extremely expensive to build. Operating costs are high, I'm sure. And personally, I wonder, you know, are they financially viable? I mean, I think there's a lot of investors wondering that right now. Dramatic scenes here. We have Atlantic Sapphire is one of the biggest RAS system builders. They may not decide, they may not rebuild a Danish facility destroyed by fire, is this recent story. Tragically, they had this disastrous fire. This company also has an extremely large RAS farm in Miami, Florida. And that's sort of a showcase facility. They're pinning a lot of hope on that. It's a Scandinavian company, is Atlantic Sapphire, and but you kind of wonder if this was a money-making farm, why wouldn't you rebuild it? That was me just wondering. Atlantic Sapphire is quoted on the stock exchange. Their shares are trading at a very low value right now. So share price is always a useful sort of indicator of investor sort of interest and concern. So I think the jury is out on RAS systems. Perhaps it'll take another 5-10 years maybe before we really know the economic reality of RAS systems, in my opinion. Moving on. So just another RAS systems, all eyes on Maine as a future RAS hub. So it's a story from a couple of years ago. But Maine has great plans for production of land-based salmon, perhaps 60,000 tons. And the government of Maine is clearly very supportive of land-based aquaculture. So, which is very good, very encouraging. Production of salmon in net pens in Maine is relatively small. I think 10,000 tons or less. Most of it in Cobscook Bay, I believe. Anyway, there's interest in land-based, as we know. Moving on. So next one's about sea lice, but my heading here, it states, traditional salmon farming is extending land-based rearing to reduce sea lice threat. So over the last 30 years, the traditional rearing plan is to, well, it starts off in fresh water, and I'm just showing the last 6 months in fresh water here in the hatchery, and it culminates in the salmon completing smoltification in May. So the wild salmon would migrate downriver at this point. In the industry, the smolts are put on trucks and transported to sea cage open net pen sites and transferred to seawater. So, And from there, the seawater phase takes about 18 months. So I've got seawater net pens here. And ultimately, we end up with a 4 to 5 kilogram salmon. The problem is sea lice. Sea lice tend to be, they're a summer problem, a summer parasite. So the traditional 18 months in seawater, the fish are in seawater for 2 summers. There used to be a very effective in-feed medicine for dealing with sea lice. But over the last few years, sea lice have become resistant to this medicine. Its trade name was called Slice. And this resistance, because the lice are resistant to the medicine, it's causing great problems, and farmers are trying to find alternate solutions to deal with the lice. So as these photographs show here, the adult lice browse on the skin and mucus of the salmon, causing death, open wounds that are easily infected and generally result in death. And the infective stage is this copepodid here. There's all these different, and it's a very tiny, it's 200 microns, like 0.2 of a millimeter, that bar there. So these are very small. The infective stage gets through very fine meshes, is probably what I'm trying to emphasize here. So this is a big problem. And I've said extending land base, so we'll go to the next slide. So what is happening is, so instead of transferring smolts to sea net pens in May here, there's this growing trend now to keep the fish on land. And this is happening in Nova Scotia as well, and Newfoundland, I do believe. But I've put Norway, Scotland, British Columbia. So the fish complete smolting, but they are kept in these land-based systems up until somewhere, I'm not quite sure, but this second, they eventually do go out to sea cages, but by this time they're quite large. So this story here is half kilo smolts will have the time at sea for Scottish Salmon Company. This Norwegian story was the same. And so the fish are physically larger, which helps them resist, or the lice don't get to them as quickly, or the bigger animals are more tolerant to lice infestation. And the bigger fish are only exposed to lice for this one summer. So you might say, oh, okay, this is very interesting. The land-based, even the traditional net pen business model is sort of being shrunk and moving to land-based because of the lice. What have I got next? Next one. Yeah, and this lice problem is not, it's in Norway, Scotland, every country who's growing salmon is dealing with this, these lice that are resistant to the traditional medicine. So there's interesting designs in Norway for new cages with these skirts here to keep the lice out. The thing is, these lice, the infective stage, they tend to stay in the upper 10 meters of the water column. They're attracted to light. So there's evidence that if you can, so that's why this skirt here is in the top 10 meters of the water column. And you might be thinking, we don't see these cages in around our parts, and you're right. I don't think they'd tolerate our currents. But the connection, next slide. I'll come back to those lice in a minute. Just another approach to dealing with the lice is cleaner fish. And there's a farm, a land-based farm just down the road from you at Woods Harbor, Pro Nova Marine. They used to be called Scotian halibuts. And they are a land-based farm. They pump seawater on shore. They are a flow-through facility, but they grow cleaner fish for, they have contract with Cook Aquaculture, I believe. The cleaner fish then get transferred into the cages where the salmon are growing. And the cleaner fish, you can see here, they actually physically pick off the lice from the salmon, which is a remarkable story. And there's millions of lumpfish, these cleaner fish that are being grown in Canada, in Scotland, and in Norway, and to try and combat the lice. So it gives you some idea of the scale of the problem and the different approaches that have been, some of the different approaches that have been taken. So this, as you know, this I just showing this projected proposed plan. As you're familiar with this land-based facility, and so thinking about sea lice. And, you know, is this a biosecure facility? So you think, okay, we're going to be pumping in seawater here. And so it's important to think about the intake screens. And the proposed intake screens have a mesh of about 1 inch wide. So these will keep fish out, but they're going to, microorganisms are going to be obviously pulled in to the on the intake here, and then we get interested in thinking about, okay, well, where is this intake? And it's 100 meters offshore, and it's 5 meters below the low tide level. So I'm speculating that there are no sea lice at those depths, because sea lice tend to be up at the surface. But that's, I'm sure, you know, everyone interested in this project would be sort of asking that question, you know, what is actually going to get sucked up and into the tanks from a fish health perspective and a biosecurity perspective. It is an important question. So the part of the solution is to disinfect the water before it gets to the fish. And the proposal includes a UV disinfection unit. So basically a UV disinfection unit, the untreated water is pumped through literally a barrel, really. And within that barrel is a very powerful UV light, so that the UV light is here. And then, so the water moves through, and then the treated water goes on to the fish tanks. So factors, water clarity is, if the water's dirty, then the efficacy of the UV light is greatly reduced. And some of these units have like a bulb cleaner on them. This is this device here. It actually automatically moves up and down to keep the bulb clean, keep the glass clean. So water clarity can affect the efficacy. Obviously the watts is important. How fast the water is going through past the UV is important, liters per minute. And the type of microbe, some cysts, microbe cysts are very resistant And some viruses are quite resistant to UV. So, and you'd need to know what was in the water and you know, say, well, is the UV lamp big enough? Does it provide a sufficient dose to disinfect the water? So its dose is light intensity multiplied by exposure time. And the units are like milliwatt seconds per square centimeter. So just from that proposal for the proposed land-based farm in Yarmouth, near Yarmouth, it's proposed to have a 70 milliwatt second per centimeter squared output. And that seems that's high. And for example, ISA viruses are zapped with 7.7. Aeromonas salmonacida, which is an important bacteria, causes that gets zapped if it's exposed to 4 milliwatt seconds per centimeter squared. So that's, you know, that's quite a significantly, that's a big UV unit that's installed. So that's reassuring, and been on that. Moving on, so thinking about the fish, and they're getting reared in tanks and settleable solids. The feces and uneaten food is obviously an important waste product. And the goal is to have self-cleaning tanks. So the tanks are circular, and the water comes in through these kind of jets to create a rotation of the water column. And that rotation of the water column generates this centripetal force that drags the solid waste to the center. A bit like if you put a bucket of slops and take a spoon and stir it, you can see like a whirlpool of the solids are drawn to the center. And so that's an important part. So these tanks, they have a center drain. It's not really rocket science, but it's extremely important method for removing solids. Yeah, and then that's that. So because in that proposal, it was stated that Cornell drains would be installed in the tanks. So we need to know about that. So why are they called? So they were invented by a Dr. Timmons, who was a professor at Cornell University. So that's where the name comes from. And so he published this design in the late 90s. So it's like this letterbox that sits on the outside wall of the tank. So here's one, there's a farm near Truro, these concrete tanks. Here's the letterbox here. And you can see a lot of water going down. And this is a halibut farm on PEI. That's a Cornell drain. And the idea is the water column is rotating, and most of the solids are being drawn into this center drain here. So we have high solids effluent and so this high solids effluent can be tapped off and put in a settling pond or managed. That's obviously the great advantage of a land-based system as opposed to net pens, that the solid waste is being managed. The water that gets tapped off at the side here, it's high volume, low solids effluent. It's relatively free of suspended solids. So it's a way of tapping off the cleanest water. So that goes in this direction. Yeah, so the waste kind of goes two ways. And I didn't see this in the, I'm not sure if this is in the proposal, but there's additional devices, like once the waste has left the fish tank, it can be sent through a swirl separator, which is a cone-shaped tank. And again, it uses this kind of swirling action to drag solids down to the bottom. And the relatively clean water is kind of picked off the top here. So there's numerous, these kind of rotating water column devices for removing solids. It's just a close-up of a swirl separator. You can see this solids here, but the relatively clean water is getting pulled off the top here, and the solids are being drawn down to the bottom of the cone. So I guess the bottom line is there's 2 or 3 methods to try and pull the organic waste out of separate the organic waste from the cleaner water. Okay, this is my, we have a brown smiley face here, and this is an intact fetal cast, which in real life probably looks more like this from an Atlantic salmon. But this is really important because an intact fetal cast will sink quickly to the tank floor, and it will be drawn into the center drain and removed from the rearing tank quite quickly. So that's ideal. But there's scenarios where the fetal cast starts to disintegrate, hence these little brown dots here. And this can be particularly dangerous in a recirc system, or if the fish are being exposed to suspended solids in their rearing tank, it can clog the gills. Chances of disease go way up. So suspended solids have to be removed by drum filter, sand filter, ozone flocculation. I believe that in the proposal there is a drum filter. Sometimes, and there are new diets coming out for fish reared in land-based systems that try and ensure that the fetal cast is intact. If worst case scenario, if the fish get diarrhea because of a nutritional deficiency or an imbalanced diet or a bad batch of feed, that can be disastrous for a land-based rearing system. Yeah, but the proposed system is more of a flow-through system. So there is going to be a lot of new water coming in relatively quickly, but I just thought it'd be worth sort of presenting, thinking about the solids and their management. I just have maybe 2 more slides. Here's just a photograph of a drum filter that, so this is a relatively small drum filter, but they can cope with large volumes of water per minute, and the drum rotates, and the small suspended particulates are trapped on the screen, and then they kind of shaved off as the drum rotates, and so they are very common in fish rearing systems. That, and this is my last slide. This is a land-based system, but it includes all the components for reusing the water. The proposed farm is flow through as we know, but I just thought it was worth showing the components. Fish tank, here's the Cornell drain here, additional solid separation device here. here's a drum filter. And in a full recirc system, then the water goes through a biofilter, which will remove the ammonia, convert the ammonia to nitrite and nitrate. So that's extremely important. And after that, we have stripper, that's for removing the carbon dioxide. And LHO is for injecting oxygen. So, and then after that, the water is back to the fish rearing tank here. So these big tanks, they have a turnover rate of like every 45 minutes, the entire volume of these tanks are replaced. And I think a similar exchange rate would be occurring in the proposed farm. Big salmon, you know, they need perhaps 1.5 body lengths per second in terms of water velocity, and there is the high exchange rate helps pull the waste out. So this was an interesting paper. It came out in 2016, and it was the first paper that presented evidence of production of market-sized salmon, Atlantic salmon, in a land-based recirculation system. So it was kind of groundbreaking in a way. They did it in fresh water. Farms there's fresh. Most of them are going seawater, I think. But so the great advantage of recirc is, well, the incoming water is filtered and pathogen free, high biosecurity. All the water, most of the water is reused per day. The wastewater is managed and disinfected. The solid waste is managed, and there's no threat to the aquatic ecosystem. Electrical power use is extremely high in these land-based farms. If you're thinking about carbon footprint, you start thinking about, well, okay, how's the electricity being generated? And, but that's another story. So that's a full recirc system. The proposed farm, it seems, is flow through, of course, and has some of these design features. So that's the end of my talk. So I hope I will stop sharing my screen for a moment. So see how that goes. Thank you.
Thank you. It was very informative. I learned lots, as I'm sure everybody else did, and folks that are watching online did as well, I'm sure. If you would entertain a few questions from the floor of the PAC. Any questions for Mr. Dustin? Oh,
Yep.
yes.
Hi.
Hi, thanks very much. I'm just wondering, you talked a little bit about the industry around the world. Does it appear to you that the industry is moving to a full recirculating system?
I think they're certainly looking in that direction. I wouldn't like to predict. As I said, I'm not sure whether it's economically viable, but it's certainly technically feasible. So I think we'll know in the next 5 years. There's so many concerns, I think, well, as you know, with coastal net pens. I talked about lice, but there's as you know, there's other issues with escapes and etc. It seems the industry is moving to land, but that's just an opinion.
So, but given with recent increases in food costs and the food insecurity that's been seen throughout the world in the last 18 months, wouldn't that make the recirculating system more viable?
Yeah, I think so. I didn't show a graph of the wholesale price of salmon. I don't have, but it seems to be going ever upward. the price of salmon in the US market. So it's like magic. It's like the demand keeps going up and the price keeps going up and for salmon. So there's that's very encouraging and for land-based, yeah, I would say.
Absolutely. Thank you. So your presentation is like, it's focused on really the safety and the health of the fish. So when you're talking about a very large UV filter, say for this proposal, and the massive amount of ocean water that it would be taking in, what would be the effects of sterilizing that much ocean water on the surrounding marine life?
I would say zero. I think that's so obviously, yeah, the water's drawn in through the pipe and it's exposed to UV, and then it goes through the fish tanks. And at that point, the threat of UV is only within that barrel where the light is. Once the water has gone beyond the UV filter, it's the number of pathogens or the microbe load has been decreased. I can't see any threat to the aquatic ecosystem.
Does it kill anything on the way in that might be beneficial to the marine life that is already in?
Well, okay. I mean, it will. UV will kill microbes, and some of those microbes are perhaps not obviously beneficial. Some of them are doing a good job. They're not all pathogenic microbes. But I think in the grand scale of things, the magnitude of the ocean and the amount of mixing relative to the amount of water that's pumped through, in my opinion, I would say it's no threat. That's my opinion.
So, and you talked about sea lice. Is it possible in a farm like this one that these fish could get sea lice? And if so, how would that be treated?
I wondered about that. I was thinking certainly the copepodid, the infective stage of the lice, is going to get drawn. It can physically get, the mesh isn't big enough, the mesh is rather large, so potentially copepodids can get drawn in. Would these little infective stage, would they get killed by the UV? I do not know. I could not find any data on the susceptibility of the copepodid to UV light. So I would say there's some potential for the fish to get sea lice. I don't know what, it's probably a low risk. So once the fish say, okay, they're in tanks, they're a lot easier to deal with in the tanks than on the open ocean. Hydrogen peroxide is used quite heavily in certain parts of the world. It's like a 1-hour bath treatment. That's one way of treating lice. On the net pens, in New Brunswick, they run the fish through warm water or some kind of shower system to try and physically dislodge the lice. So there's physical and chemical approaches to treating lice, but the risk of lice in that land-based system, I don't know. If the intake is 100 meters out and well below the low water line, I don't know, but it'd be something worth exploring for sure.
Questions from PAC? Yes, our planner's got a question. Yeah.
I just wondered if you would be able to talk about the risks of the RAS system just a little bit more. Part of the policy that we're talking about is close containment. I need that kind of terminology. And so I'm wondering if anything is ever released from these RAS systems, because I see that kind of greater than 95% recirculation, and if a system that is completely contained actually exists from your experience.
Yeah, it's a good question, and I don't know the answer because I'm ignorant of that, the specifics of, but certainly there is a certain amount of water that is released back into the environment, and the solid waste is certainly concentrated and collected in a responsible manner. I don't know. There's a farm near Truro. They get their tanks. They have settling tanks, and then it gets pumped out like twice a year. The solid waste from that, and that goes to the regular kind of municipal solid waste disposal unit. And the wastewater from this farm near Truro, the wastewater, the cleaner wastewater goes into the municipal wastewater sewage system. That much I know. But the farm near Truro is relatively small, and some of the scale of these big land-based farms is they're enormous. Some of the projections for the tonnage. So I'm waffling, so I don't really know, but it's a good question. Yeah, sorry.
Thank you. Thank you very much. Additional questions from PAC? Yes, Mr. Mo. Yeah.
You mentioned that the proposed development, Salmon Farm, has some design features that are shared by a RAS, full RAS system. Could you enlarge upon that a little bit? Which features are shared?
Well, if we think about the solid separation, that's certainly one. So the use of circular tanks and the Cornell drain is seen on RAS systems. And that last slide I showed, there was a Cornell drain there. So the way the solids are managed is, I would say, identical in a full-blown RAS to this flow-through system. The UV, I think all RAS systems have some kind of method of reducing the microbial load, whether it's so this site has UV. Another site we visited has ozone, but both of those. So I think some means of reducing the microbial load is common to RAS and this proposed farm. What else? I think that's, in terms of maintaining fish health, I think, the drum filter. I mean, I think there's a drum filter on the for removing suspended solids, and the drum filters are standard on a lot of full-blown RAS systems. Yeah, I think that's about it.
Thank you.
Okay, thank you. Additional questions from PAC?
Maybe just one quick question.
Yes.
So why were all the salmon farms being shut down in British Columbia?
Oh, well, one of the factors was this virus that I mentioned. There's evidence that this virus, PRV, that was derived from the Atlantic salmon and was posing a threat to the wild Pacific salmon. That's a very serious problem. As I mentioned, there's other scientists who are saying that the the virus was there before Atlantic salmon were introduced into British Columbia. So it seems like maybe the Atlantic salmon farming isn't the smoking gun. And whether I don't really, there's a lot of, and people just say, oh, there's a lot of politics involved. And so I don't really know, but for years, there's been a strong, consistent opposition to net pen farming. Sea lice were a big, there was a big argument for years that the sea lice were being, or the farmed salmon were serving as like a, the lice were growing on the farmed salmon, and then the infective stages were drifting out through the net pens and infecting wild salmon. That was, there was that got a lot of press for a few years. That's two of the factors I know, but there's a lot of and when big companies say it's arbitrary and unfair, I don't really understand the other side of the story, and I haven't really delved in it, but that's perhaps all I know, really. I'm rather ignorant of the ins and outs, but it's a hotly contested issue, and it's an ongoing issue. So maybe the truth will out during the next few months. And I don't know if even the federal government, will the federal government change their mind? I don't know. But the big companies like Maui are, they're trying to, we want to go through the court system we're challenging this decision. So I don't know, it seems complicated.
Additional questions from PAC? I don't see any, but what I will do is thank you on behalf of PAC. Again, another excellent presentation, as was your predecessor, and very much appreciate you taking all this time to prepare and give us a presentation and ask the questions. So I'm sure the community is appreciative, and PAC certainly is. So.
Yeah, well, thank you very much. It's been a pleasure, and if some of what I've said is of use, that's great. Thank you very much.
Thank you. Have a good evening.
Okay, bye-bye. Thank you.
Okay, welcome back, everybody. Welcome back, PAC members. And our next hour-long session is with a group of private citizens from Chile, and they are going to be speaking to us through an interpreter. My understanding is that they've been sent a number of questions that came into the municipality through the community and community members, and they're going to try their best to answer. Hello, are you able to hear us? Mark, are you able to? Oh, no, he's not.
Está con todo el volumen.
Mark, you're able to hear us?
Huh?
No sé si está.
Mark, are you able to hear us?
Yes.
Okay, we want welcome everybody. We have Carol Bartz. He's from
Josiah, sorry. I'm just using a Zoom account, my mother's Zoom account.
Yes, sorry, my apologies. And he's going to be providing interpretive services for us tonight. And we've got a group of private citizens from Chile online. And as I mentioned before, for those of you that didn't have the benefit of hearing it, They are going to attempt to answer some questions that came in through the community, our community, into the municipality district of Yarmouth office. So they've been given those questions in advance. And we're going to have it a little bit organic, but we have an hour to ask to do some presentation, ask some of the questions, and certainly interpret will be facilitating that process. So I'll let you take things away if that's all right by you. Josiah.
Yep. Hello?
Yes, hello. Yeah,
Hi.
and are you able to begin by, perhaps having either one of the citizens speak through you about their experience with aquaculture in Chile, or perhaps you could pose some of the questions and feed back the responses to us.
Okay. Bueno, es que quiere comenzar con algunas preguntas, si ustedes tienen preguntas. Y pues si quieren hablar de sus experiencias, etcétera. Y tengan en cuenta que no soy ningún traductor, que estoy bastante oxidado. Yo viví un tiempo en Colombia, así que hablen muy despacio.
Cuente su experiencia.
Sí. O sea, ¿cuáles son las preguntas que ustedes tienen para ellos? Si ustedes tienen preguntas, si quieren aclarar cosas de pronto.
Dicen que ellos comiencen, si tienen algunas dudas, alguna pregunta que comiencen.
Sí, o sea, como que quieren saber como cuáles han sido sus experiencias con esto, y pues si ustedes tienen preguntas, así si pueden comenzar así, bueno. I think so. Is there any questions, Jenny, that you guys have over on your end to start things off, maybe?
We'll have one just in a second.
Okay.
We were given the questions. We'll ask those questions.
I'm looking for that email, Jenny, that
One
sent
by
to
one.
Brian.
And perhaps what will happen is Jenny can ask some of the questions, and then we'll have questions later on from the PAC.
Okay.
I guess I'm.
Entonces estamos esperando que ellos sí tienen preguntas.
Yeah, just ask what part of Chile they're from, like an introduction from them.
Bueno, ¿de qué parte de Chile son?
Del sur de Chile, Osorno.
Okay, from the south of Chile, Osorno.
Décima región.
If you could just tell them that we welcome them and appreciate their helping us out tonight by answering some questions in terms of the aquaculture experience in Chile.
Bueno, es que primero empezar con agradecerles por estar aquí y también gracias por intentar aclarar estas preguntas y dudas que tienen.
Okay, and thank you very much. And our first question that came from the community to our municipal unit is, can you tell us about your experience living next or near to a land-based aquaculture facility? So again, can you tell us about your experience living next to or near to a land-based aquaculture facility?
Es que quiere que uno de ustedes les explique cómo ha sido su experiencia viviendo al lado de un criadero de peces, una granja de peces.
Bien, todo, Pablo, y todo lo demás.
Yo trabajo en la piscicultura. Trabajo en la piscicultura. Esta es Rahue, Copihue, así
Ok.
se llama. Y mi experiencia ha sido buena. No hay nada que sea fuera de lo normal.
Aparte que vive en Cancura.
Y vivo en el mismo lugar donde está la piscicultura. Yo vivo en un pueblo como a 15 minutos de la piscicultura.
She says that she's been working and living about 15 minutes away from a fish farm, and her experience so far has been good. If you guys want to know anything in particular, I could probably ask that too, or
Are there any particular questions from PAC regarding that question? But there,
Follow that
okay, so I'll follow up with another question from the community, and then we'll ask questions at large.
for the same person.
Yes, and so as a resident, do you experience a lot of traffic, noise, light, etc. from the fish farm?
entonces, como un residente, ustedes experimentan muchos sonidos y ruidos de tráfico o luces que de pronto provienen de ahí, o pues de las personas que vienen a trabajar.
No se experimenta mucho tráfico, es solamente cuando hay temporadas de faena, pero no es nada que uno no pueda convivir con eso.
Okay. Apparently, she says that typically there's not a lot of noise in the area. It's normally in the seasons or at the times where they're eso es como hold on a second. Eso es cuando ustedes están como es cuando están teniendo sus bebés, o como, o sea, esa palabra que usaste, no sé. O sea, tú me dijiste que a veces como hay un poco de ruido en la temporada ¿cuándo qué?
Cuando se trasladan de la piscicultura al lago, cuando ya están en temporadas que están criados los peces aquí, se los llevan, pero no es más del tráfico que hay en las otras fechas del año.
Ok, bueno, entonces aquí más o menos es cuando ustedes están depositando los peces ahí en los tanques.
Sí.
Más o menos. Okay.
No hay ruido, no es un ruido fuerte, no es algo que yo viviendo a 15 minutos de la piscicultura escucho en mi casa. No hay.
Bueno, she says that typically there's not a lot of noise. It's when there is noise, it's when they're bringing the fish to the tanks, to the fish tanks. So that would be only in at a particular time of the process. So she said that it's not a very loud noise. It'd be pretty much what comes from trucks for the most part, and machinery that are bringing that.
Okay, thank you for that response. It's very much appreciated. The next question is, has the land-based agriculture facility had any impact on your local fishing communities, industries, and your quality of life? So again, has the land-based agriculture facility had any impact on your local fishing communities, industries, and your quality of life?
Es que quiere saber cómo esto ha impactado la vida de ustedes, o sea, de la economía y también de lo que sería la pesca que viene de mar, o sea, cómo ha impactado, o sea, ese negocio.
Debería hablarlo.
Sí. En cuanto a la economía.
Repita la pregunta.
Es que
En cuanto a la economía,
sí, la economía de la pesca que viene del mar, o sea, que estoy suponiendo que ustedes, o sea, están operando en tierra y ellos quieren saber cómo eso ha afectado a lo que viene del mar. O sea, yo no sé cómo cuán tierra adentro lo siento, están, pero ellos quieren saber cómo ha afectado su negocio, que está como, supongo, tierra adentro. a ese negocio que proviene del mar, o sea, lo que ellos, o sea, si se ha afectado ese negocio.
De la etapa del agua. ¿Éramos tú explícalo?
Ya, y yo dije,
Hola, hola, mi nombre es Erasmus. Más que nada, acá las pisciculturas se cría el pescado en su primera etapa, peces en su primera etapa. No es que dañe mucho, digamos, a las otras especies o las otras producciones como son las del mar, porque acá la primera parte que se hace de los peces, ¿no?
Sí. Y ustedes, o sea, como para yo saber, o sea, ustedes están muy alejados del mar, o están como muy cerca. O sea, yo no conozco mucho como la geografía de su país, entonces.
Lejos no estamos, pero igual está en la parte central del país, po.
Sí.
Nosotros por lo menos estamos como a 80 kilómetros del mar, 100 kilómetros del mar.
100, okay, bueno.
Sí.
And so he was saying that that it hasn't really affected much of that of the fishing there, at least what's done in the ocean. But obviously, they're a little bit further away from the ocean than obviously we'd be here, right? So, but yeah, it hasn't really affected, or they haven't seen any effect on what would be fishing coming from the sea.
So, thank you for the response. Can you speak of can you speak to the positives and the negatives to having this facility in your area? So again, can you speak to the positives and negatives to having this facility in your area?
Bueno, él quiere saber cuáles son los pros y la contra de tener un negocio así. O sea, ¿qué han vivido ustedes? O sea, tanto como lo bueno y lo malo de tener un negocio así. Y pues quiere saber un poco de las dos cosas.
Contra, nada mucho, porque la cosa de la piscicultura, por lo menos a la gente del sector, le ha dado más que nada trabajo, el mismo pueblo, porque aquí hay un pueblo cerca de la piscicultura. Yo creo que más que pro se han visto beneficiados.
Sí.
Aquí puedo dejar una persona que vive en el sector, que yo igual trabajo acá, pero no vivo un poquito más apartado.
Mi nombre es Jessica y la piscicultura lo han ayudado harto ahora último por la estabilidad de la economía. Hay harto trabajo, tanto para las mujeres como para los hombres.
She says that what they said for pros is first off, the work is quite close, and because of the job isn't quite as physical probably as being on the sea. There's a fair bit of work for both women and men. So that'd be the pros. ¿Ustedes pueden pensar en algún negativo?
Algo negativo, no sé qué vive ahí en el...
¿Alguna contra?
No negativo casi nada, porque en cuanto a los ruidos, la contaminación no es mucho lo que acarrea.
She says that there's not a lot of negatives because there's not a lot of noise pollution and most of them all live quite close. Y más o menos cuántas personas emplea su granja.
Como 30.
30, 35.
En esta agricultura son como 30 más o menos.
Sí.
So there's about ¿cuánto?
30 aproximada. 30
She says that their particular firm hires or employs about 30 directly, 30 people directly, and obviously then there's going to be the people that work as truck drivers and whatnot that might only be employed as almost like a third party.
Thank you very much. Excellent answers. And the last question that came in from the community, does the facility take away from the natural beauty of your coastline? So again, does the facility take away from the natural beauty of your coastline?
Bueno, es que quiere saber, bueno, yo sé que ustedes ya han dicho que no hay mucha contaminación y eso, pero él quiere saber como si quita brillo de la belleza de lo que sería la costa de tu país. O sea, yo sé que ustedes están un poco más alejados de eso, pero pues, o sea, si, ¿cómo te digo? Si es fea como esa región.
Parece que estamos un poco confundidos por lo que estaba escuchando, porque piensan que nosotros estamos a orillas del mar, ¿o no?
Yo pienso que sí.
No, ahí estamos confundidos porque estamos al borde de un río.
Sí.
Un río que es relativamente grande, tiene harto efluente, pasa harta agua por el río.
Bueno.
Pero por eso yo creo que estamos medio confundidos. Un río, bueno, navegable.
Pero aún así no se nota tampoco la piscicultura a la orilla del río porque no está a la orilla. No.
Claro, pero no estamos instalados sobre el río tampoco, estamos a la orilla de un río.
So he said, as far as coastline, as far as coastline, he said obviously they're a ways away from it, so they're probably about 60, 70 kilometers probably from the coastline, but where they're next to is going to be lakes and rivers, so that's where they're next to. That's where the water and that would be coming from for their fish farm.
So perhaps we could take a little bit of time, maybe if they could introduce themselves individually and maybe indicate what they do. And I'm Chair Trevor Cunningham, and perhaps after we'll go around and introduce ourselves, and then we can take some questions from the floor of the PAC, Planning Advisory Committee, which is this. Okay.
Entonces lo que quiere saber es como uno por uno, o sea, quiere saber como cuál es su nombre, su trabajo, su labor, y eso en el negocio. O sea, no tiene que ser como una respuesta muy larga, o sea, más bien simple, más al grano.
Una presentación, una pequeña presentación. Bueno,
Sí.
empecemos por allá. Javier, no sé si se ve, a ver, ahí no, cambiarlo de puesto. Sí.
¿Lo de pie?
Echemos unas pocas. No, tu nombre, en qué te desempeñas, básicamente, tu experiencia.
¿Entró en la cámara?
Ahí está.
Hola.
Hola.
Me llamo Pedro. Trabajo en el rubro de transporte. Por aquí cerca en el sector igual.
So this is Pedro. He works with transportation, pretty much in the same sector, same area.
Thank you. Nice to meet you.
Next.
Que pase otro, ¿cierto?
Sí, claro, sí, claro.
Tú eres vecino de acá, ¿cierto? Trabajador. Eso es que...
Hola, buenas. Gloria Fernández. Trabajo como ayudante de cocina. Bueno, mi experiencia trabajando con la piscicultura ha sido satisfactoria para mi familia y también yo creo que tener una piscicultura cerca de un pueblo es lo más bueno porque le da trabajo a la gente. El pueblo crece a través de que ellos traen personas a trabajar. Hay pensiones que a veces no tienen gente y a través de la piscicultura han crecido bastante el pueblo de Vancouver.
¿Y cómo te llamas?
Gloria Fernández.
Gloria. So this is Gloria Fernandez. She works, I believe, in the kitchen as a chef, and she helps to provide a living for herself and her family. So one of the things that she likes is that the job is close to the town, and so it's able to allow the town to grow a little bit and provide employment to the people that live nearby. Bueno. Y pues hay otro, hay siguiente.
Just a point of clarity, are all these folks working for the company?
Es que quiero saber antes de empezar si todos ustedes trabajan para la misma compañía.
No, entre comillas, sí, pero en diferentes rubros. Por lo menos la persona que pasó antes de la señora acá, él trabaja en transporte, igual para la empresa, pero aparte trabaja en otras partes.
So some of the people in here work with third-party companies as well. So this isn't, some of the people that we're talking to, this isn't their only source of income. They come in as third-party. Other people work full-time. So.
Very good, thank you.
Bueno, entonces puedes empezar si quieres.
Ya, entonces, bueno, me llamo Erasmo y trabajo aquí en la piscicultura. Mi trabajo es operario de mantención y antes igual trabajé, pero de operario en los pescados, con los peces, digamos. Y durante estos 10 años que llevo acá trabajando ha sido igual muy satisfactorio lo que para mí, para mi familia y es una muy buena experiencia, no nada que decir.
Entonces tu trabajo sería de tiempo completo.
Yo tiempo completo.
Sí. Y bueno, entonces tú alimentas y eso es tu trabajo más o menos, como la alimentación, la filtración de agua, etcétera. Eso es lo que haces.
No, yo estoy en la parte de operación, en la que es mantención, lo que tiene que ver con bomba y cosas así, lo que ocupamos para hacer llegar el agua a los estanques.
Sí. So it's like, ¿y cómo te llamas?
Erasmo.
Erasmo?
Sí.
So this is Erasmo. He works full time at the fish farm. His job would be everything from maintaining the filtration systems, the cleaning, feeding the fish, etc.
Thank you very much.
El siguiente.
Es importante que hablen los vecinos del sector, porque ya habló los trabajadores.
Aló, buenas tardes.
Buenas.
Lorena, soy Lorena, vecino de la localidad.
¿Y cuál es tu trabajo? O sea, si lo puedes explicar.
Manipuladora de alimentos.
Entonces, o sea, tú, ¿qué haces? Es como mezclas, como haces, o sea, ¿cómo sería tu día? O sea, entiendo más o menos qué es lo que haces, pero pues...
Cocinera.
Cocinera. Lo siento. Bueno, disculpa. Bueno, ¿y cocinas para los peces o para los que trabajan?
Para el personal que trabaja en la piscicultura.
Ah, bueno. So she works as a chef. She cooks for the people that work in the at the area, and her name is Lorena.
Thank you very much.
Bueno, ahora llegó una nueva integrante. Ahí preséntese, ¿no? Después hablan ustedes, porque son externos. Que no está muy claro ahí que es externo.
Hola, hola, ¿qué tal?
Bien, ¿tú? ¿Cómo te llamas?
Bien, me llamo Julio Gastón Toro Ríos, soy guía de pesca con mosca en la ciudad de Osorno y en la región de los lagos, y soy presidente de la agrupación de guías y pescadores con mosca de la provincia de Osorno.
¿Y qué haces? O sea, en tu trabajo, más o menos, ¿qué es lo que haces?
Como guía de pesca, flotamos todos los ríos que están en la región de los lagos, incluyendo el río Rahue. Bajamos haciendo pesca catch and release, pesca deportiva, y bajamos los ríos desde el lago Rupanco, de donde nacen hasta donde terminan. Pasamos pescando por los bordes de las pisciculturas y por toda esta zona.
¿Y tú llevas esos peces a los tanques, a los criaderos?
No, nosotros hacemos pesca deportiva.
Bueno. Entonces tú no trabajas en ese negocio. Bueno, entonces que nada más vives por ahí.
Yo trabajo en el río.
Bueno.
Con fly fishing.
Bueno.
Pesca con mosca.
Sí. So this is Julio. So he doesn't actually work there. He lives in the area. His job is more sport fishing in the lakes, so it doesn't have anything to do necessarily with what they're doing there. But obviously, that's his job in the area.
Thank you so much.
Y pues si hay otro.
¿Otro?
Ahora tienen que decir que son vecinos porque no trabajan en las casas, los que ustedes dos ustedes pasan con algo, porque yo creo que están contigo.
Mi nombre es Jessica, yo soy vecina de acá de la empresa, trabajo en una planta faenadora de vacunos.
¿Y tú trabajas para ese negocio?
Sí.
Sí. ¿Y qué es lo que más o menos haces? Como, ¿cuál sería tu trabajo diario? No sé si lo puedes explicar.
Aseo industrial.
Entonces, o sea, ¿qué es exactamente? O sea, que tiene que entender que yo no sé nada de su negocio, nada de eso. O sea, entonces que estás hablando con un bobo.
Es una planta donde se faena vacuno.
Nada que ver con los pescadores.
No entiendo.
No entiendo.
Que sí, porque no trabaja con los
la
agricultura.
Soy
vecina del sector.
Que nada más vives ahí, o sea, o si trabajas para. ¿Cómo es?
Soy vecina de acá de la empresa de la piscicultura.
Bueno, sí. Bueno, eso es lo que no entendí. Ya. She just lives nearby. She doesn't actually work there. So she just lives in the neighborhood, essentially. And her name is Jessica.
Thank you.
Y siguiente.
Sí, pero que para que quede claro que eres vecino del sector, no, porque está enredado. Claro.
Yo me había presentado ya, me llamo Pedro, pero para que quede claro, soy vecino acá del sector.
Bueno. So this is Pedro again, and he lives in the neighborhood as well. So. ¿Y hay más? ¿Ya hemos hablado con todos?
¿Todos son trabajadores?
El resto son todos trabajadores.
Bueno, sí. So the rest of the people in there are all workers. We've kind of talked to a little bit of both workers and just people living in the area. So
This is very helpful. Perhaps we'll just go quickly the.
Or maybe we just ask the question.
You
Yeah,
can introduce yourself. Okay. So we'll just, I will just entertain some questions from the floor of the Planning Advisory Committee. So does anybody want to ask folks some questions? Patty Durkee, Councillor Durkee.
Hola, my
Hola.
name is Patty. My name is Patty, and I want to know if from this company, does the water flow back into any of the water that surrounds the organization?
okay. Y yo quiero saber si el agua de ese negocio donde están los peces y eso filtra, vuelve al agua como de los ríos y eso después. ¿Cómo es el sistema de filtración?
Retorna el agua que se utiliza en la producción de peces.
Sí, más o menos si el agua que se usa en la producción, en los criaderos, si eso vuelve a los ríos o a los lagos.
Sí, retorna al río de forma limpia. Tiene un proceso de limpieza antes de devolverse al río.
So there's a system of purification, and it will return back, I understand.
Additional questions?
So to answer that question, like if you guys got that, like there is a system of purification, they say, and the water does return. I guess it'd be almost as groundwater if I understand it right, but after it goes through a system of purification. So.
Thank you.
Councillor Durkee, you have a follow-up?
No, I'm good, thanks.
You're good. Additional questions? Councillor Cushing.
Just ask them, do they have a lot of tides down there? There's a lot of current along the coast?
They're not on the coast.
They're about they live about 60 to 70 kilometers away from the coast. Yeah. So.
Additional questions from
I
PhD?
mean, city, they're a good town.
Perhaps the name of the city again that they're in?
Yeah, I don't exactly know how it's pronounced. Maybe if somebody could write it. Oye, Pedro, ¿me puedes escribir el nombre de su pueblo o ciudad en el chat para que no sé cómo pronunciar?
El nombre del lugar. Del pueblo.
Sí, como de tu pueblo, sí.
Cancura, el que está más cerca.
Sí, donde ustedes viven y donde está el negocio.
Cancura se llama el pueblo.
Sí, Cancura.
A 25 kilómetros de Osorno, que es la ciudad más cercana, más grande.
¿Me lo puedes escribir aquí en el chat?
Escribirlo. Ah,
sí.
El chat, acá está el chat.
So he's gonna write the name of the place because I don't know if I'm hearing it right. So.
Thank you.
But yeah, he says it's about 60 to 70 kilometers approximately from the coast. So.
Yeah. Oh, there's.
Okay, all right. So it's Cancura. It's Cancura. Yeah.
Very good. Yeah. So we've been able to locate it with Google Earth or Google Maps. So
yeah,
that's great. Yeah, it's on the west coast of Chile, and I guess there is only one coast from Chile.
There's only one coast.
Yeah.
Across the nation. So that's wonderful. That's a great connect. And are there any additional questions? Casey? You have one? Yes. It's our CEO, Chief Administrative Officer Victoria Brooks, who has a question.
Hola.
Hola. Hello.
I was interested to know from the gentleman who's involved in the sport fishing, what types of challenges or problems there may have been, if any, and what was done to overcome them.
But with respect to,
The land-based aquaculture and the outflows into their rivers and streams.
okay. ¿Cómo se llama ese señor que trabaja con el pescado, con el deporte? Bueno. ¿Y cómo te llamas otra vez? ¿Cómo te llamas?
Julio Toro.
Julio. Bueno, Julio, ellos quieren saber si de una u otra manera, si ese negocio ha impactado o si ha afectado tu trabajo, o sea, con lo que sería como en cuanto a ese agua que vuelve a los ríos y eso, si eso ha afectado tu trabajo.
No ha afectado mi trabajo. El agua que vuelve a los ríos se ve bastante limpia siempre cuando pasamos por la zona de desagüe.
Sí. ¿Y ha habido algún inconveniente para ti? O sea, sea por el tráfico,
No, nada. Al contrario, hemos hecho actividades de limpieza del río en conjunto con la piscicultura.
So he said not that he's seen with the, because obviously it goes through a filtration system, so he hasn't noticed any issues, at least with the contamination side of things. And he said that it's brought a little bit more work for him and his job, being that there's a little bit more people, a little bit more traffic going through the area.
We're just, as a follow-up, please,
Yes,
Mr. Chair,
certainly.
just how long has the company been operating in that community?
Okay. ¿Y más o menos cuánto tiempo lleva ese negocio en ese lugar? O sea, aproximadamente cuántos años o meses.
¿La piscicultura de usted? 11 años.
About 11 years, a little bit more.
Excellent, thank you. Additional questions from PHC members or staff? Mr. Hilton, Councilor Hilton.
Hello, my name is Nick. I'm just curious if it was difficult finding a job prior to the farm being built there. Was this economically, did it change the community at all?
Él quiere saber como cuán difícil era antes de poner el negocio, si era difícil encontrar trabajo en tu pueblo.
Sí, era complicado buscar trabajo acá en el sector. Había que salir fuera del pueblo para encontrar un trabajo. Estable, porque esta piscicultura es un trabajo estable, que dura años.
Y antes que había, o sea, como yo desconozco su pueblo, antes que había de negocios, de empresas.
Era solamente trabajo de campo, agrícola nomás, nada más.
Entonces eso sería como la cultivación de tierra, como de como la cosecha. Okay. So before is primarily like a agricultural place. They would have fields. I'm not exactly sure what they grew exactly, but they said that there was a little bit of difficulty before finding work outside of the town. At least stable work that wasn't seasonal. So being this is a little bit less seasonal, it's been given a little bit of more stability, I guess, to the people living around the area.
Follow-up?
Yeah. So when it comes to the treatment of water, does anyone come to the farm to test the water, or is it only looked at on site?
Okay. Es que quiero saber si alguien viene a la granja a testear, a ver cómo son los niveles de contaminación de agua antes de que ese agua vuelva a los ríos y los lagos.
Sí, se hacen monitoreo constante. Hay equipos instalados en el retorno del agua igual, tomando ciertos parámetros, CO2, temperatura y varios parámetros más que toma el equipo. Aparte de unos filtros UV también instalados en un sector
y más o,
antes de que retorne al río el agua.
sí, y más o menos, y más o menos como cómo es la filtración, o sea, que pasa por varios tanques antes de llegar al río, o sea, antes de eso. O yo sé que hay alguien que está monitoreando el agua como para ver
Pero
qué tal está.
antes de llegar a los estanques donde están los peces, hay un sistema de filtro UV. Luego pasa por los estanques donde están los peces, donde ahí también se monitorea. Sacan muestras de CO2, temperatura, ¿qué más éramos? Lo más común que sacan, el CO2 y la temperatura y oxígeno, que es lo principal. Luego pasa por los estanques, hay un sistema de decantador y hay rejillas también, hay filtros antes de devolverse al río. Trata de limpiarlo lo más posible. Y antes de también se monitorea.
Sí.
Hay unos certificados, empresas externas que vienen también a sacar muestras y para ver si cumple con...
Y la persona, la persona que está monitoreando eso es alguien que trabaja para el mismo negocio, es una persona que trabaja para el Estado para garantizar que
no, son externos y también hay entidades que lo contratan a la empresa, se puede decir, para ir contractando las muestras. Pero también hay externos, hay el Estado también, hay una entidad que se llama Cernapesca que está encargado de monitorear todo el tema acuícola relacionado con los peces y el agua, los ríos.
So the way it works is that there's a series of filtration systems. The water passes through these filtration systems. There's somebody that comes and tests regularly. It's not somebody that works for the company. It's somebody that works. I guess it's a government worker that comes and monitors it before it returns as groundwater, essentially. So they have a system of I guess it'd be I'm just trying to think of the word in English. It's I guess like screens. It's essentially would be a screen so that the excrement doesn't return with it.
Thank you very much. Additional questions from BAC?
So, and before, like, so he was saying that obviously, like, along with the testing, there's also, they test like levels of oxygen and the temperature as well. So it's not going in there warmer or colder than what the temperature outside would be. So.
Well, that's helpful. And again, I'll ask one more time. Are there additional questions from PAC members? Yes, Mr. Kamo.
Warner Kamo, can you ask Julio if he's noticed any effect on the fish in the lake that he works on?
That's it?
That's it, yeah.
Okay. Julio, ¿quieres saber si tú has visto algún efecto en el pescado, en los peces donde tú pescas? O sea, que podría ser como el resultado de contaminación, etcétera.
No, yo llevo bajando el río 8 años.
Sí.
Y no he visto efecto en los peces, nada.
Y por lo general, o sea, tú puedes pescar cerca de la orilla, o tienes que ir como muy adentro como para...
No, porque yo paso en bote, digamos, y recorro todo el ancho del río
Sí.
y kilómetros de río.
Okay. So he hasn't noticed anything himself. I asked him if he's noticed that he has to go further away to find fish. He said that it hasn't been the case, but so it apparently it seems like it's a fairly big lake. He says that he's quite far in, sometimes even kilometers in, so.
Thank you. Additional questions from PAC? There being none, listen, I would like to extend my thanks and the thanks of the PAC members and the community staff for all the time that these folks have taken to answer our questions. It's very much valued, and certainly it gives us a broader perspective of aquaculture globally, certainly. So we're thankful for their time and efforts in extending us this help.
Entonces, él dice que quiere agradecerles su tiempo y su colaboración con este chat. Y pues, is there anything else you'd like to add?
No, we're good, and thanks again, and I hope that they're able to visit Canada, or we're able to visit Chile at some point.
Dice que espera que algún día ustedes pueden visitar Canadá o si ellos pueden visitar Chile.
Perfecto, gracias.
Bueno,
Gracias.
Bueno, cuídense mucho.
Gracias, igual.
Chao, chao.
Chao.
Ciao. Thank you, Mr. Burke.
Yeah, no problem. Take care.
Take care.
¿Un cafecito? Una
agüita mineral. Una agüita.
Una buena es. Ya está la
I did it for you.
Okay, very good. We're back. Three very good presentations, an opportunity to certainly hear from a number of experts and to ask questions of varied groups. What we will be doing tomorrow is again starting at 9 a.m. There'll be three presentations that will take us through to 12:30, and then we'll be recessing again at 12:30 tomorrow, and we'll be coming back on Thursday, November 25th, again for one more presentation at 3:30. So there being no further business, I'll look for a motion to recess the meeting until October 26th, which is tomorrow at 9 a.m.
I'll make that motion.
Councillor Cushion moves, your seconder. Yeah, Mr. Trask, Trask seconds. All those in favor?
Aye.
Aye. All those opposed? Okay. Meeting recessed.